Good morning, guys. How are you? It's such a pleasure to be here for the second day for the Porto Tech Cup conference. This is the second day and the last day of this conference for this year, and we are very excited to start with Mohit Sharma. Mohit, good morning.
Good morning. How are you?
I'm fine. For those who are entering now, we were here, me and Mohit were here talking about weather. Mohit is based on in Ireland right now, and he's going to talk us about Kotlin Multiplatform. Mohit, thank you so much for accepting this invitation. It is really a pleasure to have you here. And let's start with a good fit, Mohit.
Thank you.
It's you. It's yours.
Thank you, Luis, for hosting me in and for providing me such a great opportunity to talk within your group circle. I'm really pleased. Okay, guys. Good morning, everyone. I know it's very early, but it is, right? So thank you for joining in once again. Today, I'm going to share my thoughts on Kotlin Multiplatform. So before we get down to the actual business, let me give you a small brief. We'll be talking about the basic introduction of myself, why Kotlin Multiplatform is required, a little basics of Kotlin Multiplatform. Then let's try to see how we can get started with Kotlin Multiplatform. Then post that, we'll see a little code of how to build your first Kotlin Multiplatform. And then we'll have a small Q&A. So just a small disclaimer or information which I like to go before we proceed. This talk is primarily intended for developers who have heard Kotlin multi-platform or have very little experience with the platform. Okay. What I'll say, the key takeaways for this talk would be that you will understand what are the benefits of Kotlin multi-platform and how you can leverage it in your application. So let's go ahead then. So again, I'm Mohit. I'm a mobile developer for approximately 12 years now. I started my career working as an Android dev with Android 1.5. So I'm a decade old now, I'll say more or less. Okay. Currently, I'm working with MongoDB as a developer advocate for RHEL. Prior to that, I was working with Dubizzle in Dubai as a mobile evangelist. And prior to that, I was leading a mobile team at To The New in Delhi. My Twitter handle is Code with Mohit. Feel free to reach out to me during the talk or after the talk. Share your opinion. I'll be happy to listen to your feedback. So enough of me. Let's go ahead. So Realm. Okay. So what do I do at Realm? So basically, Realm is a open source mobile database. Okay. It's not SQL. It's not relational. It's an object database. And we are built primarily for people who believe that mobile applications should be offline first applications. Okay, you shouldn't work only when the internet is alive. You should be alive throughout any moment of the time user opens your application. It really makes sense to have a object-oriented database for, especially for mobile developers, because we get most of our data in around NoSQL format and a JSON format, and then we try to convert it into objects, and then we manipulate around that. So most of our life cycle revolves around objects. So trying to save it into tables, relational tables, doesn't really make sense. And also saving in JSON is not really great because you lose all the power of querying. But with Realm, you don't have to worry that. Apart from that, you get, if you want to sync, you get that feature out of the box with Realm. It has many other cool features like function triggers, auth, GraphQL APIs, etc., etc. We support these platforms. So you can find our SDKs available on all these platforms. So you'll eventually understand why KMM makes sense for us. So Our team has like an year back decided to scrap the old Android SDK, Java SDK, and rewrite the whole thing from the very scratch using KMM. Okay, so enough of about me and my promotions activities. Now let's talk about KMM. So why KMM? Before we jump down to the actual question, let's try to understand a little bit of a history around mobile development and see why there is a need of any platform like this. So mobile development has been there for a decade now, right? And since very early days, people have been trying to solve one problem, the very basic problem. Can we have one code base that can build mobile applications for all the type of OSs, be it Android, iOS, Windows, whatnot, right? So the real intention or the logic reasoning behind this was that, you know, if you have one code base, it will be a less time for you building any feature or shipping any feature. Less time in turns reflect to less code. Less code in turns reflects less bugs, right? We don't want bugs. Anyone doesn't like bugs, right? And at the end of the day, when you have less code, it means you don't need a heavy team on a developer side as well, right? And in turn, in the final, which all the company bosses look for, less money, right? And last and most importantly, for developers like us, it kind of follow a notion of don't repeat yourself pattern. Okay, so if you're trying to repeat your application apps from one platform to another, is you're kind of breaking that pattern on a psychological level at least. So to solve this problem, there have been a lot of platforms available since very beginning. PhoneGap, Titanium, Cordova, Ionic, these has been there for such a long time, and all of them were trying to solve just one problem: how can we build apps that are proficient, and write the code at one place, build it for all the platforms. But in my opinion, instead of they solving the problem, they made problem more complicated. So what I remember from my experience, one of the problems which I faced when I was exploring the Cordova, Ionic, or Titanium was that the app experience was lost, because Android user will feel that he might be using an iOS app because it was primarily built from an iOS app perspective, or the vice versa, right? So user gets confused. From a developer perspective, it was pain because there was a very low community support. So if you wanted to build something unique, niche, no, if you get stuck, you're stuck forever, right? That was a problem. If you have been a mobile developer, you must have heard the key parameter of 60 fps, right? So 60 fps was the bridge which says that if your application is going below that, that means your application is most likely stuck on the user face, right? So when you're using such kind of a hybrid platform, 60 fps was a big problem, and people were trying to come as close as possible. But the situation got improved later on with the big players like React Native and Flutter coming into picture. And for sure, I will say that the community support and the acceptance within the market is also very high. But still, right, people want to build apps as proficient as possible. So at the end of the day, I believe that people wants to build an app with one code base, but with the performance of native apps. Let's try to look this from another perspective, from a perspective of a developer. So I've been a developer for a very long time, and it has happened to me many times. Like I'm running late on one of the features, and my counterpart, my other developer, iOS developer, is running ahead of me. I used to think, I wish I could have just simply copied the logical code for me, like the logical code, I meant to say the business logic, or how to extract data from the internet and save it on the mobile. I wish I could have copied that code, but Sadly, I couldn't do that, right? Because it's a very altogether different programming language. My platform doesn't support that, and vice versa for him as well. Like, he never got that opportunity as well, right? So we were always thinking, like, is it possible to have a mix of something? And for mobile developers, hybrid apps doesn't make a very good choice because they always feel that it's going to be laggy. So that was another perspective on this thing. So now let's try to break down the problem into very small chunks. First, we want to have one code base for our mobile apps. Why so? Because I believe that most of our application code is only business logic. Business logic, I meant to say, getting the data from the internet and manipulating over that. And the rest of is just UI, which should differ on platform to platform. Which brings us to the notion that why can't we have one common module, okay, which can write this, business logic or getting extraction of data from the internet for me. And there could be some provisioning via which it can be exposed for me, uh, and then I can write the platform specific UI so that my UI is still very like performant, and I still able to leverage the common code base, right? This seems to be a very good idea, right? This is what Kotlin multi-platform is, and this is the problem they have been trying to solve from past few years. So what they propose is very same, like have a common code base, have a common code for the things which are common to the both for the applications, and they'll expose those things for you, and over the top of that you can just use those datas and expose to APIs to build your UI or whatever you want to do it. Since I've been a mobile dev, I'll be probably talking with respect to Kotlin multi-platform for mobile. Okay. In simple notion, you will hear it people saying it as KMM because Kotlin multi-platform for mobile is too big. Okay. So simply people say it KMM. So Kotlin multi-platform in general also supports other platforms as well. Like instead of just mobile, it also supports very other platforms. It supports browser-based platforms as well. You can build your native applications for Mac OS, Windows, or Linux with Kotlin multi-platform. And it also has a niche support for variables like watch OS, TV OS, etc., etc. So now let's see what is Kotlin multi-platform. So I would say that Kotlin multi-platform is nothing than just a collection of Kotlin modules. So the basic module is the common Kotlin module. It includes all the common code which can be used or can be run on all the platforms. It tries to enforce the philosophy of reusing the logic in a common code. To interact or to interrupt with the platform, we use platform specific versions of Kotlin, like say for example Kotlin for JVM, Kotlin for JS, or Kotlin for native, right? So basically it's a wrapper over the top of them, which helps you to access the platform specific APIs so that you can write platform specific code over the top of that, which is further exposed to you to the platform native solutions, wherein, let's say for example, activities and everything, wherein you can just simply use it to build your beautiful application UIs. And the build process also remains the same. There is no difference with that. Builds can be built in the same manner. The artifacts remains the same. So there is no other changes with that. Now let's try to see the project structure of a Kotlin multi-platform. So this is a basic Kotlin multi-platform project structure on a high view. Okay, as I mentioned you earlier, like it will have 3 modules: the shared one and 2 specific related to Android and iOS. So this is the shared one. The shared code base is primarily responsible for writing all the shared logic. As I'll read it once more. The shared logic is get the data from the internet, try to sort it, try to filter it, or any other business logic if you want to do it. Grab some data from some other source, aggregate it, and then pass it to the UI. Okay, so all the thing which has to be done with the data manipulation has to be there, should be there in shared module. And then there are two other modules, that is the Android and the iOS, wherein you will just try to build your beautiful UIs over the top of the data which has been exposed by the shared module. But there could be few cases wherein you would like to, you would like to write some platform specific code in the shared module. One of the use cases could be, let's say, for example, you want to access the location of the user, right? At the end of the day, you want to use application, you want to use a common functionality, let's say for location, but it is platform specific. Android has its own way of doing it. iOS has its own way of doing it. So how do I do it? So in that case, what Kotlin Multiplatform suggests is that in the shared module, you can write your platform specific code in the platform specific folders. So here you can see the split of the shared module. It has two folders, iOS main and Android main, and the common main. Common main is the actual way where you write the common logic. So I was mentioning you that how do I write platform specific code, right? Which can be used on both the platforms, right? So one way, as an any traditional developer, you'll think, okay, why don't I create an interface? Okay, and then I write the implementation of that interface in both of the modules, right? Pretty straightforward, traditional thing. But Kotlin multi-platform suggests one more way of doing it. They proposes a concept of actual and expect. So actual and expect declarations are the Kotlin mechanism of developing Kotlin application that needs to access platform specific API that we implement based on our needs. With this mechanism, a common source set defines the expect declaration, and the platform source sets must define the actual declaration that corresponds to the expected declaration. This feature works out of the box for most of the Kotlin declarations. Let's say, for example, functions, classes, interface, enumeration, properties, etc., etc. So on a high level, it looks something like this. You define an expect function or class, and then based on that expect, you define your actuals in both the platform, Android and iOS, and then you can do whatever you want to do with that implementation. Let's try to see a little more into detail how we can do it. So this is a very simple example. Here I want to create a random UUID, and I want to use platform specific APIs for that. In Android, it's Java utils. In iOS, it's Foundation Kit, right? So how do I do that? So then I define my expect function random UUID of type string. And then when I go to the Android main, I just simply say, okay, the actual for that expect is UUID got random ID dot toString. And on the iOS side, I do the similar. I define my actual random UUID string as NSUUID dot UUID string. As simple as that, right? Very similar to the interface, but it kind of symbolizes here how we do it in Kotlin multi-platform. Another a little more complicated, or how do you do it? Like earlier was just for the case of a variable, here is case for a class. So here we try to define, okay, what is my platform type? Okay, the platform type will keep on getting varied based on your platform, whether it's Android or iOS. So again, we define an expect class saying, okay, this is my platform, which will have a member variable called platform, which will return me the type of platform I am in. So on Android main, I'll simply go again, I'll implement this expect as an actual, and I'll give the definition of it. Same, I'll do it for the iOS as well. Let's look down to another concept. So if you have been coming from the Android world, you must be aware of the suspend function, and you must be loving it, right? Because it's a very clean or a nice way of doing things asynchronously. So with the suspend function, what happens if you're not aware of that? So what is suspend function in general? Like, it's like a foundation of asynchronous or non-blocking programming in Kotlin. We called it suspend because basically whenever the function is called, it suspends the code flow at that particular point till it doesn't get the response out of it, and then lets you go. The benefit of this is that you don't have to worry about the callback hell which we used to get with other platforms. Okay, and it's very clean and imperative way of doing things, and promotes reactive programming as well. But sadly, there is nothing like nothing as this there is no concept like this on Swift and iOS, right? So then it becomes a kind of a bummer for us. But you don't need to worry for that, because Kotlin multi-platform made it possible for us to do that. What it does is, when you write a suspend function, internally the code compiles back and gives you a callable function for that. So it becomes a normal callback method for you. So you can normally access that method in the Swift as a callback function. So as soon as you get the data or the response, it will be thrown back you as a callback. The flow remains the same, so you don't have to worry about things. Now, this is the overview, but most of our Android work, day-to-day work, also depends on a large number of third-party libraries which we use for many purposes. So let's try to look at few of the things here. So Ktor is one of the libraries which is heavily used in Kotlin multi-platform. It is also promoted by JetBrains. Okay, it's a networking library. You can use the kind of modules you want to have for it. It's an optimal replacement for retrofit. I've heard people saying that now they don't want to move back to retrofit after they started using Ktor. Um, Now, once you get the data from the internet, you would like to extract the data as well, right? You would like to extract it to your objects and work around it. So for that, you have Kotlin X realization, which is very similar to JSON if you have used it in your past. Once you have extracted your objects, now you want to save the objects. You can use Realm, right? That's why the library is there for us to help us out. For any other purposes, I found this repository. It's a very popular repository. It has a list of tons of other Kotlin multi-platform libraries supported. It ranges from dependency injection to logging to testing and everything. So do get a chance to check out this library. So now let's see how to get started with Kotlin multi-platform. Just give me a moment, please. Getting started with Kotlin multi-platform is very simple. So for the environment setup, you don't have to do much. You just need to have an IntelliJ or Android Studio, and then uh, just install the Kotlin multi-platform mobile plugin. What this plugin does, it helps you create Kotlin multi-platform out of the box. You don't have to manually create the projects for yourself. So just installed it. Once the plugin has been installed in your IntelliJ or Android Studio, when you create a new project, you would be able to see the option of creating a Kotlin multi-platform application. With the recent update, you would be able to see Kotlin multi-platform libraries as well, right? Okay, so the library, the Kotlin multi-platform KMM is evolving very quickly. Once you select the KMM application, it will ask you for very basic details, like, say, for example, what is the name of the application, package name, what is the minimum SDK you would like to notify for the Android, then what kind of dependency manager you would like to have for the iOS, and the name of the common shared modules, Android and iOS, what we seen earlier. In my personal opinion, I will recommend you not to change the naming convention because it's kind of a pretty much standard. So it will avoid having a small learning curve within your team if some new members join it. So once that is done, it gives you a hello world application. One of the other benefits which I see with this plugin is that you don't have to go to Xcode for just running your iOS application. You can do it within the Android Studio itself. So both of the platforms code can be run within one ID itself. You would have to go and open Xcode in case when you want to write iOS specific or a Swift specific code. That's the only case I see. So this the screenshot of the project which you get out of the box. We'll be seeing this project in more detail. How did they build it? But let's try to understand how the Gradle has been set up or what's under the hood that made it possible. So when I look at the Gradle file, I see a few of the plugins that have been added. So they added a Kotlin Multiplatform plugin. They added a CocoaPod plugin, which is used for the dependencies in iOS. Then we defined the Android part as a library project. Makes sense, right? Now, suppose that there is another block wherein you define which kind of platforms you would like to use. So on the top, you see I have defined Android because I want to make sure that my app runs on Android as well. Then I have defined my iOS. For iOS, you need to do certain extra things because of the dependency manager and everything. Then after that, you define your common source, your Android specific source, and iOS source. In the same way, you can define your testing source set as well. So, okay, now let's go and see how it is done actually. Okay, so this is my KMM project. Yeah, this is my KMM project. As I mentioned you earlier, you could see that I have Android, iOS, and shared module. Okay, and if I run this project, I think so the project is already running. Let me see, where is it? Yeah. Okay, so let me read on it. So this is my project. I have rerun it, so hopefully it will run very soon. Okay, I'll not go and create the blank new project because downloading dependencies takes some time. So I'll try to avoid that to save some time for us. Okay, so you see that I'm running the iOS emulator from Android Studio, right? Okay, one thing which which I'll recommend you if you are trying to do a small hands-on on the Kotlin multi-platform, go with the stable version of Android Studio. Don't go with the beta or the canary ones. I have a habit of going to canaries, and it really got me into trouble when I was using Kotlin multi-platform. So I'll recommend you not to do that. You will also see one of the errors coming in with Kotlin multi-platform is that it will give you that you're not using the Java 11 or something like that. Okay, so in that case, although you might be using it, but I don't know, it's a bug in the platform from the IntelliJ side itself or from the Kotlin multi-platform itself. I'm not really sure on that. But for that, I'll recommend you just add this functionality or declaration in your Gradle.properties. That will get resolve that. Suppose that you don't have to do anything. As soon as you hit the play button, it will install or download all the dependencies for you, and it will run automatically. So let's see from the Android perspective what the code is there. So for now, I'll just switch to Android code and I'll see. Okay. So as you can see, it's a very small code. It does nothing. It has a text view and it is getting the greet message from somewhere. right? So greet message is getting from this property called greeting class. Okay, now let's try to see this greeting class. So this greeting class is nothing, a normal class where it has a function called greeting, and it tries to get the data from the platform. Okay, what is this platform now? Okay, platform is nothing but an expect. You must be remembering the concept which we just talked earlier, expect and actual. So let me go to the actual implementation of this. Since I'm on the Android side, just go to the Android part of it. Okay, so you see here that the code has been switched to the Android side of it. Okay, so I could see, okay, the platform would be Android OS version blah 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 blah. Okay, now let's try to go it on the iOS side of it. So here I'm using the UI kit for accessing the device version and everything. So it becomes very clean and simple, right? How do we do it? Okay, so again, going back to the project mode. Okay, and going to the Xcode side of it. Okay, similarly, it has been accessed in a similar fashion on the iOS side, greetings, and then we are trying to create a view out of it. Okay, and it runs out of the box very easily, smoothly for you. Okay, so that's a small code logic I want to show you. Let me check if I have missed something else or not. Yeah, and that's pretty much on this side. Okay, and the rest of all the other things remain same. If you want to add any other dependencies, you will go to the shared Gradle file and you will add all your project dependencies here. Okay, depending on the kind of libraries you wanted to have and whatnot. Okay, now let's go back to the presentation again. Okay, now the main thing comes in, the decision whether you have to use whether you have to use KMM or not. Um, so the decision depends on a lot many factors. You will have to try to understand whether you actually need KMM or not. Just don't try to switch with the technology, whether it really makes sense for you to use KMM or not. In my opinion, most probably it will make sense for you if you are working, if you are creating a product which serves for both of the platforms. Okay, it definitely makes sense for those organization which works in domain, like say for example of photos or camera or something like editing like this, because at that in those kind of application you want to use the native platform APIs. Okay, and also wants to give an immersive experience to the UI. Then what do you think how the team will feel? Definitely there would be some kind of a hindrance when people are migrating towards a newer platform, especially with the platform which is a kind of a new or in an alpha phase right now. Okay, it's still a developing platform, but try to understand how to gauge whether what does the team feel about it. You will feel some kind of a hindrance from the team, especially from the iOS side, because for them the learning curve is better higher, in my opinion, because they have to learn Kotlin multi-platform as well and the new language as well. So for them definitely there will be some kind of hindrance. Few of the advantages and disadvantages, in my opinion, with respect to the platform. I'll start with the disadvantages first. So as I mentioned you just earlier, that the APIs are still in the alpha mode, but the Kotlin multi-platform has declared that by spring of 2022 they are going with the beta release. So you can expect a lot more stable changes. Even with the APIs in alpha version, at Realm, we never realized that the platform is too buggy. It still has few bugs as it's an alpha API, but we are pretty much happy, and that's why we even decided to build over the top of that. When you're trying to set up the project with plain your hands instead of using the Kotlin multi-platform plugin, it becomes a kind of a problem. Okay. And it is painful because of all the kind of cryptic messages you get. So Gradle configuration with plain hands is kind of a painful experience. As I mentioned you earlier, you will get some kind of a resistance from the iOS teams, and there will be some kind of a discussion or arguments among the team as well, like what kind of architecture you would like to have for the common application, and how do you migrate with it. Okay, so these are the few cons which I see when you're migrating to Kotlin multi-platform. But let's see what are the pros for that. By nature itself, Kotlin multi-platform promotes the pattern of separation of concern, or don't repeat yourself. So by default, programmers are forced to follow that pattern. Okay, so that's a very good thing when it comes to have clean code, or when you want to improve the testing coverage of your code, because now at the end of the day, your Android specific code and your common code will be forced to get separated. Okay. One other benefits is Kotlin. So definitely Kotlin is one of the very popular languages, and it's growing like anything. And I definitely loved Kotlin, the way how the APIs have been structured, how clean or how easy it is to use. Another thing is, as a difference with respect to any other hybrid platform, it doesn't uses any hybrid kind of a mechanism to access the underlying platform APIs or anything. It just gives you the native code and just ask you to use it directly as you used to do in native application. So definitely, the performance hinges or the barriers which we used to get earlier would be not here, as in my opinion. uh, Commitment is also very low. So let's say, for example, you decided to start, you wanted to start a new project, then the process is very straightforward. But what if you want to add it to your existing project? In that case, also you can start with one of the very small feature, and see for yourself how is it working for you, whether it's really helping you or not. Okay. In my opinion, the learning curve is also very low. Okay, it's very low. You don't have to learn too much thing, except like, even if you're thinking to write, how will you write from an Android perspective, how will you write iOS code? I would say that Swift and the Kotlin have kind of shared a similar kind of a programming paradigm, so it becomes kind of an easy, and you'll be able to switch it, and likewise goes for the iOS as well. So that's my take on this. Um, I would like to thank all of you for listening to me patiently. Um, I'll be open to the questions, my slides, and if you have any other opinion, please do reach out to me at my Twitter handle. Thank you, everyone.
Thank you, Mohit. How was it?
Good.
Be,
I enjoyed it.
your first time in a Porto Tech conference.
I really enjoyed it. And now I wanted to hear the public's people's opinion, how whether they like my talk or not.
Yeah, that's right. As I told you, people during this hour are still kind of waking up. So, guys, if you want to put some question to Mohit, please do it. Mohit, I'm pretty sure that the questions will come during the day. So I would say that up to people to also to put the questions on your official Twitter. I think you have, right?
Yeah.
So yeah, basically people, I'm pretty sure they will do it directly to you on your official account Twitter. Mohit Sharma, it's been really a pleasure for you to open the second day and final day of this international conference for the first time digital. Thank you very much for sharing this awesome content with us, and have a nice week.
Thank you. Thank you once again for hosting me as well. See you
Thank you,
later.
Mohit. See you.